Today, we will be looking at the service's branch equipment and associated techniques for extinguishing compartment fires. This video covers the following topics: firefighting branches, branch couplings and attachments for non-compartment firefighting, gas cooling techniques, and direct attack techniques. The service carries two types of hose reel branch and two types of lay-flat hose branch. The Delta Automatic H500 is the default branch for high-pressure hose reels using water or standard firefighting foam. The branch has an on-off stirrup handle for flow control. Spray pattern and flush settings are adjusted by rotating the front bumper. Whilst the multi-purpose nozzle is suited to a wide range of firefighting scenarios, the branch is ideally suited to compartment fire situations where flashover risk from igniting gases is the main concern. The Anglocar misting branch and associated attachments are specialised tools for non-compartment firefighting. The branch can be changed from the primary mist setting to a secondary jet setting by rotating the front bumper. The misting branch and attachments are ideally suited for fires where limited water or reducing water runoff are the main concerns, such as fires in the open, car and skip fires, and chimney fires. The Delta Attack 400 is a higher flow rate branch for low pressure lay flat hose using water or standard firefighting foam. The spray pattern is adjusted by rotating the front bumper, whilst a flush setting is incorporated into a separate flow control ring. The branch is mainly used for firefighting in larger compartments or where greater volumes of water are required to deal with specific risks, such as fires in high-rise buildings or as covering jets. The Delta DM600 is a high flow rate mainline branch for low pressure lay flat hose using water or firefighting foam. The branch has an on-off stirrup handle and is fitted with an automatic pressure control tip. Closing the handle will reduce the flow of water through the branch, whilst the automatic tip adjusts to maintain the throw performance. Spray pattern and flush settings are adjusted by rotating the front bumper. The DM600 can be used for firefighting in larger compartments and is also ideally suited for cooling tanks or buildings to reduce the risk of fire spread. The Delta H500 branch is connected to 22mm hose reel via a McDonald style coupling. The branch operates at high pressure, typically around 30 bar. Removing the branch is a simple process of unscrewing the safety collet, pulling back the spring-loaded collar, twisting the branch through 90 degrees, and gently pulling away from the coupling. To fit a branch, bring the couplings together so the raised connecting lugs align. Press the couplings until the spring-loaded collar is pushed back. Rotate the branch through 90 degrees so the spring-loaded collar clicks back into place. Finally, screw up the safety collet, ready for use. The misting equipment suite has 3 attachments which operate at high pressure, typically around 20 bar. The default attachment is the branch head, which is able to extinguish non-compartment fires using significantly less water than other branches. This reduces the amount of contaminated firewater runoff created and, by extension, the environmental impact of firefighting action. Changing the misting attachment simply involves undoing a second McDonald-style coupling located on the branch. The misting attachment can be changed with the hose reel pressurised, providing the stirrup handle is fully closed. Unscrew the safety collet, pull back the spring-loaded collar, and twist the attachment through 90 degrees. The misting branch has an internal filter to stop the fine spray components from clogging. The filter should be used when fitting each attachment, with the open end of the filter pointing towards the branch. The lance attachment gives firefighters more defensive options. When combined with hole-making equipment, such as the percussive rescue tool, the misting lance can be used to extinguish fire without needing to gain access, such as through a car bonnet into an engine bay fire. Alternately, the lance allows defensive firefighting from outside a fire compartment, such as at this industrial unit where fire spread was prevented using defensive misting techniques. The final piece of misting equipment is the chimney attachment, which is connected using the same McDonald-style coupling method. The chimney attachment is used in conjunction with the chimney rods. The rods are screwed into the attachment, which enables it to be pushed up a chimney to extinguish fire. The Delta Attack 400 and DM600 branches connect to lay-flat hose via a 64mm instantaneous coupling. They operate at low pressure, with 4 to 7 bar at the branch being optimum. They are secured in the coupling by 2 spring-loaded lugs. These lugs are pulled away from the coupling simultaneously to remove the branch. Compartment firefighting is when firefighters attempt to contain and control a fire at the earliest opportunity, typically within the rooms or compartments of origin. Such offensive internal tactics minimise the chances of fire spread, reduce the level of risk to casualties, and, to some degree, decrease the exposure to risk for firefighters. Gas cooling involves the distribution of finely divided water droplets into the hot gas layer, using a pulsing action. Gas cooling is an intervention that tries to control combustion taking place within the fire gases, and is predominantly a means of reducing the likelihood of flashover. To be effective, an optimum spray pattern, sufficient pulse length, and an adequate flow rate of water must be achieved at the branch. Imagine this firefighter is gas cooling in a compartment. They want to get water into the hot gas layer, so it turns to steam and cools the gases. If the compartment is reasonably large, with a boundary wall at the red marker, the firefighter needs to narrow their cone angle so the water actually reaches the hot fire gases. Suppose the compartment is smaller, with the boundary wall at the blue marker. Now the firefighter is jetting the wall, rather than achieving steam in the hot gas layer. They need to widen their cone angle to gas cool effectively. Another key factor in successful gas cooling is using long enough pulses, and therefore a sufficient quantity of water, to be effective. In this demonstration, a firefighter is going to gas cool with very short pulses, too short for the compartment size and fire conditions. You can see the gas cooling has had very little effect on either the neutral plane or controlling combustion within the fire gases. Now let's see what happens when gas cooling is done using a sufficient quantity of water. Again, a firefighter is going to gas cool, but this time with pulses long enough for the compartment size and fire conditions. This time, the gas cooling has had a meaningful effect. The neutral plane has been forced to the floor as a sufficient quantity of water has expanded into steam within the hot gas layer. There has been a significant reduction in flaming combustion, both within the fire gases and, to a lesser extent, within the seat of fire itself. Let's look at the effect of water expanding into steam within the hot gas layer in more detail. The firefighter puts two pulses into the upper corners of the compartment. The displacement of hot fire gases is significant, as steam has an expansion ratio of between 1,700 and 3,400 to 1, depending on the temperature. This expansion forces hot fire gases and steam away from the seat of fire and out of the compartment. If the firefighter were in the compartment, the gases would be forced over their head, potentially compromising their exit route. For this reason, it is good practice after gas cooling to promptly perform a safety zone, so a second steam expansion cools and limits the fire gases travelling past you. The final key factor is having an adequate flow rate of water. There will come a point where either the elevation, such as a high-rise building, the conditions, such as heavy fire loading, or the compartment size, such as in a warehouse, make a hose reel ineffective for compartment firefighting. In these situations, firefighters should consider using media with a larger diameter to maintain a higher flow rate, such as a 45mm or even 70mm lay-flat hose. Whilst the branch techniques remain the same with larger media, firefighters should be aware of an increase in jet reaction. Remember, firefighters can always revert to defensive techniques if firefighting media is proving ineffective. We have covered gas cooling as an intervention that tries to control combustion taking place within the fire gases. However, simply cooling gases will not put out a fire. The most effective means of extinguishing a fire is a direct attack, applying water or other firefighting media in a jet, spray or other form directly onto the seat of fire. A direct attack may follow after fire gases have been suppressed using gas cooling techniques, or after compartment boundaries have been cooled using indirect methods. Firefighters should not become overly focused on gas cooling techniques when the direct application of firefighting media is required to extinguish the fire. Direct firefighting has the potential to generate large amounts of steam. Firefighters should consider taking measures to ensure they are protected from steam burns and the increased heat in the fire compartment. For example, they could adopt defensive or safe positions behind substantial available cover, such as doors or walls, or consider using tactical ventilation. Let's review what we've covered. The service carries 4 primary branches. The Delta H500 is the default branch for hose reels, which can be used for compartment firefighting. The Anglocar misting equipment, comprising the branch, lance and chimney attachment, are for non-compartment fires, such as fires in the open, car and chimney fires. They also provide firefighters with some defensive misting options. The Delta Attack 400 can offer a higher flow rate by swapping from a hose reel to lay flat hose, and the Delta DM600 is another step up when a high flow rate is needed. These branches can be used for compartment firefighting, using the same branch techniques, but be aware of the increase in jet reaction. We've covered 2 principles for compartment firefighting: gas cooling and direct attack. Gas cooling is to control combustion occurring within the hot fire gases. To be effective, the branch needs a suitable spray pattern, achieved by widening or narrowing the cone angle to suit the compartment, remembering safety zones to protect your exit route. The optimum pulse length puts enough water into the hot fire gases to be effective, but be aware the more water you put in, the more steam you create, which can worsen conditions for firefighters. An adequate flow rate is needed, taking into account the elevation of the fire compartment, the fire loading and conditions, and the compartment size. If a hose reel isn't effective, consider firefighting media with a higher flow rate. A direct attack is for extinguishing fires. Firefighters should not become overly focused on gas cooling when the direct application of water onto the seat of fire is required to put it out. Be aware that direct attacks can generate large amounts of steam. Consider a direct attack from behind cover or using ventilation.